There are two main things we talk about when we say this is good code. But before I show you, what do you think good code is? Think about that. What would you tell somebody if you're asking them to write good code? All right, I'll just give you the answer. You see, good code can be described in two things, or 2 points. One is readability. Is your code just generally clean? Can others understand your code? And then we have scalable code. What does that mean? Well, big O notation is what allows us to measure this idea of scalable. Code that can scale. Something that we're going to get into and you're going to become more familiar with as we go through this section. We're also going to talk about readable code throughout this entire course, but touch upon it a little bit more in the next section. But for now, because this is the big O section, we're focusing on this idea of scalable code. Okay, what does this really mean though? Well, I want you to imagine we have a task where we want to bake a cake. We have a recipe over here, and this recipe we're going to use in our kitchen to bake a cake. And there's a good way of baking a cake and a bad way, right? We give it the instructions, that is the recipe, and hopefully this recipe and instructions work well with our kitchen so that we can bake a cake quickly, and a good cake at that. Well, computers are machines, and these machines need to work in order to produce something for us. And computers work in the same way. We have these instructions that we give it through code, and these instructions that we give to our machines, our computers, give these instructions that provide for us some sort of an output. For example, to turn on the light. We give the computer instruction to say, hey, turn on the light in our room. A coder is someone that gives these instructions. Just like there are many ways to take a cake into a kitchen, or just like there are many ways to bake a cake in the kitchen, with many recipes, ingredients, and instructions, there are many ways to solve a problem through code. There are efficient and inefficient ways to give instructions. So let's go to a coding example. I'm going to use REPL.in. And if you're not familiar with this, make sure you check out the video that I've listed down below here, which explains how you can run your code in this course. I'm going to just log in. And I already have my JavaScript environment set up over here. And I prefer having the dark theme. I think that looks better on your eyes. For you at least, I hope you don't mind the darkness. But how can I demonstrate this idea of code? Let's do something fun here. Using JavaScript, I'm going to say const Nemo. We have an array that contains the string Nemo. And we want to create a function here that is called find Nemo. And this function is going to receive an array. And it's going to be a very simple function. We're going to create a loop that you'll see in most languages. In JavaScript, we can do that easily by saying for, and we'll give let I equals 0. And as long as I is smaller than the array.length, that is the length of our array, and then we're going to increment I every time. Again, this isn't a JavaScript course, so hopefully this is familiar to you. Any sort of loop that you want in your language. And we're just going to simply say that if array I equals Nemo. So if we find Nemo, we're just going to console.log found Nemo. We're very excited we found it. All right, that's it. And if I just simply run the function now, find Nemo, and we'll just give it the array Nemo over here, and make sure that I spell length properly, and we click run here, we have found Nemo on the right. Let me make this a little bit bigger so you can see. So we found Nemo. This is the instruction that we gave the computer. We told it that we have an array, and we have a function, an action that we want to perform called find Nemo that takes an array, which is Nemo. It's going to receive this array, then it's going to loop over the array. We're going to say that I is going to equal 0. And because I is 0 right now, and the array.length of Nemo is 1, we're going to go through the loop. We're going to check if array index of 0, which is Nemo over here. So this is going to turn into Nemo. And because this is true, we're going to console log found Nemo. Now, why did I just show you this example? Let me just bring this back to the way it was. I showed you this example because this is an instruction that we're giving our computer to find Nemo. You see, we call this the runtime. How long does it take to run a certain problem through a function or a task? How can we measure the big O of something like this, or the efficiency of this code? In the next video, we're going to get a little bit deeper. We're going to try and measure the performance of this code and see what happens when the array gets larger and larger. And we're going to tie things together as to what scalable means and how big O allows us to measure this scalability. See you in the next video. Bye-bye.